All right, here is my speed run of Malice in Wonderland, the Excel Esports case. First level here, I'm just subtracting time. Excel time comes in days, so I have to multiply by 24 to get hours, and then by 60 to get minutes. And that's all there is to do for that one. This one, these are 2 characters long, right? It's 20 drinks. I need to start at 1 and step by 2, right? Because I need to mid starting here on the start number going 2 characters, right? And now I've got the drinks. Then I need to know, which drink is it? So if this equals this, then the multiplier is 0.2. Otherwise, it's 2. So you either get cut into 1/5 or you get doubled. And this thing I got has got to stay locked. Start at 72, then your new size is just that times that. Although you get ceiling rounded, right? According to the instructions, that's kind of the tricky part is you got a ceiling rounded every time. And now I just need to find how many drinks it takes you to get to 1. So I just X match 1 on here. That's how many drinks it takes you to get to 1. Now we're going to do the caterpillar riddle, which is this. I want to do this together. I want to have a little room, so I'm going to put it in a new place here. So the hint says to do the bottom first, which is a very good hint, right? Because this is the only way to solve the bottom. It's got to be two of these and 2 of these. There's nothing else is possible. So now, if I know this, right? So now I'm going to look at these possibilities and see which ones are eliminated already. So I split this by the comma. Then I'm going to use my exists lambda to check on this array if this number exists or not. Then I'll filter to get the ones that do, or I almost forgot, I got to change these to actual numbers. Right now I got to filter on this array where it does not exist, right? So these are the ones that are still legal to put there, right? So these are my options for the answer. And, there's only one option here, so I can do that. One option, right? And this all just fills itself in, right? There's only one option left as I go through this puzzle, as long as I do it correctly. Don't get confused by the script that I probably should have changed to regular font. Yeah, so that's 3 and that's 20 and that's it. Okay, the 9 is the example. The rest of them are the answers. All right, this one is just, string to array to get the letters. I would need to know if it's capital to know the multiplier. So if, exact, not, well, I could leave if, why not? Exact this and upper of this, if those are exactly the same, that means it is a capital letter, so 2, otherwise a 1. And then, the base is, I'm going to look this up. Can't subtract code minus 64, but this actually, I'll use the if missing lookup to handle like the spaces and the punctuation relatively easily. So I like this style a little bit better, as long as I keep this all locked. Should work pretty well, right? And then it's just a sum product, but I have to prepare for this going on and on much longer. So there's that also. Sum product of this and this here. All right, Tea Party color are here, right? So I got to do equals x to call of all the Tea Party colors. So this is here, this is here. Now I text split this to go out. I mean, all that Lambda did, right? It's just put that data in a long format. It's just like toCall, only it added the addresses also and has some other funny options that I'm not using at the moment. It's a big thing, so it takes a minute to calculate that, but you know, not that long, not too long where it's not a good solution. All right, so now the difference here, right, is just the ABS of this minus this summed up. And then I will use the, oh, so I got a small one's got to be locked, of course. And then I have a smallest lambda that just finds the smallest one of these, the smallest difference, and returns it on the addresses, which is what the question's asking for. All right, so now we're going to do this courthouse of cards. Get string to array. This time they're only one character each, right? Are they always the same length? Yeah, these are all the same length, right? I got to look these up on my arrows that I have prepared here. Diagonals are not allowed in this case, luckily. Oh, did I miss one? I missed the up arrow. Sorry, up arrow. I didn't mean to forget you. I need the up arrow too, right? The hint here is actually very helpful. It tells you that I totally missed that those hints even existed when I was solving it the first time. But the hint's like, hey, you should total up the arrows. I'm like, that's a great idea. So here are the arrows, and then count if this whole thing locked is that. But I got to do, I got to use the actual correct arrows for this though. So it's this one, this one, this one, and this one. All right, and this is still in order, right? Yeah. Okay, so the row change and the column change. What? These are my arrows. These are also arrows. This is in arrows, and this is, you know, this stuff. So this times that, you know, just add all this up, right? That's the row change and the column change. So the final coordinate is based on my starting coordinate, right? So the jack of clubs and this, I'll call this the court, right? It is here. There's 13 of these. So this is the 12th column and the first row. 12th column 12, row 1. So it's column 12, row 1. So the final row and column is simply this plus this. X mod is my one base mod, right? Because it goes from 1 to 13 instead of, you know, 0 to 12 or whatever. Is that right for the row? No, the rows are, there's only 4 possible rows. So that number of rows and 13 possible columns. And then now it's just index on the court, right? So on the court, I look for the row and the column. All right, we got some fun bonus questions this time. Oh, did I not start a clock for this? I did not start a clock for this. Oh no, there it is. Okay, it's just not in its right place. The bonus questions. Okay. Sum of the red values in the Tea Party. I mean, Tea Party values are all right here, right? So the red is the first one, right? RGB. So all of those together is not a number because I didn't make these numbers. Take a second because it's 16,000 rows. All right, so now I need to do, the sum of here to there. The cat, what happens if we take all these colors? Well, I could do it in VBA, but I'm not going to because I don't have to. Instead, what I'm going to do is I'm going to make a new one, and I'm just going to take the first value, right? So text before this semicolon, right? So that's the red value. All right, don't want a background for this. But what I do want is a conditional formatting, but based on actually being numbers again. You got to multiply by 1 to make it a number. All right, so there are the R values. If you look closer, these cats are all 255, 255, 255, right? But anyway, there's a cat, there's a cat's nose, so 90. All right, 100 glasses of wine from 72, so that's what, 100. No, it's 2 to the 100, right? So 2 to the 100, this is like a high school math problem, right? I wrote this on a paper when I was doing it live, right? It's 2 to 100 times 72, right? And then the log of that base 5, right? So log of that base 5, and it's got to be ceiling rounded because the magic potions do ceiling rounding when you drink them, right? 2 to the 100 times 72 divided by 5 to the x. Solve for x. It's 46. All right. King randomly moves. Where does he end up? When I first did this, I thought it would be whichever one's like the furthest, but that is not the correct answer to this question at all. So let us figure out the actual answer. The mathematical way to solve this correctly is not a high school math problem. It's more of a graduate school math problem. So we're not going to do it that way. But we could just do it empirically, right? Like if we do 10,000 tests, I'll bet we'll get the right answer. Let's see. So now, the arrows here. How am I going to make 10,000 random arrows, right? So let's do it like, I still need this, right? So these are the numbers. Let's say I assign the arrows 1, 2, 3, and 4, right? So I'm going to start with rand array 30 rows, 1 column from 1 to 4 as an integer, right? So those are the arrows. So I'm going to call that arrows, ARROWS in a let. And I need to know the row changes, right? Which are X lookup the arrows on the arrow key, right? Returning the row change for the arrow. And this is going to get copied a lot, so it better be solid. So I'm going to do this a little bit different. I'm going to, well, no, actually, this is fine. No, I've got an idea. How about this? How about I do this and then save array, right? So this is going to save this array. This is going to make my arrows, right? So here's 30 arrows saved. I'm going to do this sequence 10,000 times. I'm just using this as a guide for my double click, right? And then I'm going to paste value so it's not volatile anymore, right? So now I've got 10,000 sets of random arrows. So now let arrows be load array, right? So just turn this back into an array. And the row change now is XLOOKUP the arrows on here locked, returning here locked, right? So if I do row change, I'm going to get a bunch of zeros and ones and stuff, right? So I can sum that up to get the total row change for this set of arrows, right? And then the same thing for the, you know, I'm not even going to change the name of it. I'm just going to move it over like this. And even though the name is wrong, I know that it's a column change because I looked it up on L. So this is row change, this is column change. Formula for the row and the column is the same as it was in the regular level, right? It's just X mod of that plus of the starting coordinate, right? Plus that mod the total number of cells, right? So it's the same as that. And then the card, right, is just the index of the court where we do this and this. But it's not I've got too many parentheses, not enough commas. Oh, okay. So there's 10,000 random trials of this. That, oh, something's not locked. Court, why is this getting value? Yeah, okay. Why are you, oh, because I'd written the starting coordinate up here. All right, so the starting coordinates are I don't know, 12 and 1. Yeah, 1 and 12. All right, so the starting coordinates are 1 and 12. So that is 1. This is 12. And I'm going to copy those down. All right, so now I've got my cards, right? So if I look at, you know, the court, here, I'm going to count if each member of the court on this entire thing locked. And we'll see if we can notice a pattern here, right? Count if is, I've got that reversed, array first, then the value. So out of 10,000 trials, this is our distribution. And we can see that the least common cells are this one, this one, this one, this one, this one, and this one. All right, so if you look at these, diamond, club, diamond, club, spade, the only one that's a heart is the 7 of hearts. So of these rare ones, the only one that's a heart is the 7 of hearts. All right, now, Caterpillar's riddle continued. Now we cannot use these 4 questions we're relying on anymore, right? So ignored those. We know the answer. The only fixed answer is this 9, right? So actually what I'm going to do is I'm just going to get rid of the 9s from here, right? So, you know, replace 9 with nothing because the 9s are not options for these. This one I don't have to worry about, right? This is just 16, 18. This is 2, 6. Okay. So now I've got to solve this riddle, which is a very tricky problem. I could not figure this out. I watched Dim's video on this, which helped me understand. So let's start with text split, right, of this by the comma, of course. We're also going to add a leading 0 to the 1-digit numbers. And the reason for that is that I want to search for, I want to make a long string and then search for a 2, but I don't want it to find 12 because that's, I want only, if I'm searching for 2, I want to search for 0, 2. So now those are all unique symbols. So what I want to do now is say, okay, so what if you got to pick one of these, then you got, so I can't do brute force, right? Brute force, too many combinations. So instead, what I gotta do is every step I've gotta see that, all right, so if I picked 8 here, now I can pick 5, 10, or 11. Those are all legal and keeps branching, but I gotta cut off the parts, the illegal branches before I move on, or else I'm never gonna solve it. So to do that, right, what I'm gonna do is something like this, right? So this first one is just the base case, right? So it's just this, right? So now so this is my, so, you know, my old list is here, right? F1 array. And my new list is here, right? Those are the new numbers that I'm going to be testing. Now, one thing I could do is, let's say I do old and a delimiter and new, right? Oh, but I wanna flip one of them, right? So to call this, so it's vertical, right? So now I'm taking a vertical and a horizontal, and I ampersand them to concatenate them, right? And I get every possible combination. So you pick 8 first, then 5. You pick 17 first, and then 5, right? So now what I got to do is I got to see if any of these are illegal, right? So if they're illegal, I got to cut them out of the list now, right? So to do that, it's not too complicated, right? So what I want to do here is I'm going to do a if find, right? So I'm finding the new one within the old one. Right? So if that is an error, that's actually good, right? Because I don't want to find it. If I find the new one, that means it's illegal. I'm killing it. But if it is an error, that's good, right? So in that case, I do want old and new. Otherwise, I want an NA error, right? Because then I'm going to filter that out in a second. This is probably good the way it is, right? So in this case, nothing showed up as illegal, right? But like if I had, let's say if this was 11, right? 1111 is illegal. So now it says NA, right? So I'm filtering out the illegal ones at each point. So now what I have to do, so like let's say let's go back to that case again, that this was 1111. So now I got to take this, I'm going to call this, you know, the I don't know, results. Now what I want to do is I want to do 2-row results, getting rid of the errors, right? Because I need everything to fit on that row. 2-row results, that's how you get rid of errors, right? That's the end of the let. This needs a comma here, right? So these are the legal combinations, not counting the illegal, right? There would be 9 if 1111 was allowed, but it's not. So the illegal one is removed, right? And then you just keep building on it, right? Building on it, filter out the illegal ones every time along the way. And then at the bottom, you count the number of columns. And it is 1 because I forgot the array symbol. It is 1,000. Sorry, let's check one more time. 1,356. 1,356. Nope, that's not a 6. 1,356. All right, I'm not done yet. Got 1,009 points. Does that mean I got an entire level wrong? That would be bad. Oh, I didn't even do level 7 yet. We got to do level 7. I don't know why I switched to the bonuses. I mean, here I'm going to do that. I'm doing everything out of order tonight. Why not? All right, now let's do level 7. Level 7 is not bad. I got stuck doing it the first time, but now I know how to do it. because those are not really borders, right? Which if I'd read the instructions, I would have seen, right? These are actually, you know, cells that tell you like where the walls are, right? So I'm just gonna have Alice look at every location. So like if Alice is here, I'm just gonna have her look in each direction and see what she sees. And if she sees a wall, she's gonna stop. And whatever card she sees, that's the answer. All right, so we gotta move up, down, left, and right again. So up, down, left, and right. I'm going to do what? The addresses and then the contents. All right, so the addresses here are arrow move of this. This is just for the first row. And this, right? And then the second row I'll have to deal with separately. But this G actually has to lock, even though I'm only using it once. Okay, now arrow move this by this locked. All right, we just keep moving in that direction. That should be plenty of moves. Eventually, you hit the wall. Is this not doing the right arrow? No, yeah, it's not doing the right arrow because the arrows are always locked. All right, yeah, that is not. That has to be locked to the correct arrow. Like that. This has to be locked to the correct arrow like this. Boom. Now we got to look up the contents. So I just make a little X to call of the whole thing here. And X look up this on here, returning this. Keeping this thing locked, right? This is just the first one though, right? Because, and also it'll be missing sometimes, which is fine. That just is a blank cell. And then the rule is, so if you, as soon as you see a one, you got to stop. So if there's a one there, then, so if the cell above it equals one, then just stop. Just don't even bother looking it up. Otherwise, yeah, keep looking it up for me. Otherwise, we're going to keep looking up and see until we see a card, right? It's got to be locked. Yeah, I grabbed the parentheses, so it won't lock. Parentheses are wrong, but it looks like we've got it here, and I need the if missing. It's just another nothing. Should be fine for this. All right, and this is what we see. There's, you know, she has now seen the 5 of hearts. This is probably overkill, but that's fine. To pull the first non-1 value, all right, first let me flatten it. All right, this is the order. This will also be in the order that I want. So that's the order she's seeing things in. And then I filter this where this is not equal to 1. And that will leave me with the card. Ta-da, come on, you can do it. This was a 40-minute case, even though my speed run is taking almost 30 minutes. So there's a lot in this case. So a couple of those bonuses were real tricky. Fun though. This hopefully I don't have something else. Oh, right, there is 0 is an answer that's allowed. So I will have to I'll just manually put in the 0 since that's faster than redoing the whole table. So this is fine, and then the one that's missing needs to be a 0 because the instructions say do 0. All right, boom, 29 minutes 11 seconds. I should explain the court one a little more. I think I probably didn't explain that one super well. Hopefully the riddle one sort of made sense, how this builds. You know, like it builds the legal cases, and then the search filters out the illegal cases, right? This find here filters out the illegal cases, and just leaves you. It just builds the cases, because if you keep building, if you don't check for illegal cases every time, then you've got you know, 3 to the 16 possibilities, right? Minus those the couple twos here, right? But like, you know, that's more rows than Excel has, so we can't test every possibility. We have to filter out the illegal ones. This answer to the courthouse of cards is actually very counterintuitive until you notice a little bit about how it works here. The 7 of hearts is right next to the Jack of hearts, right? So the first time I saw this, I was like, oh, it's got to be like over here somewhere, right? Because this is like the farthest, that this is the most number of moves to get over here, right? But it's not the most number of moves. In fact, it is the least number of moves. It is only one move to get up here, but it is the most rare. And the reason for that is that you can't is that if you look at these row changes and column changes, because they're an even number of arrows, 30 arrows, either both of these have to be odd or both of them have to be even. So, you know, both even, both odd, both even, both odd, both even. It's the only possibility. You cannot have one even, one odd. So, in order for the king to accuse the 7 of hearts, he would go 1 column and 0 rows. That's an odd and even, so that's impossible. The only way to get to 7 of hearts is not to just go up 1, but is to go all the way around. It has to be up 1 and over 13 to get back to the 7 of hearts. That's why this is so rare, right? Another way to think about this is if you're going an even number of arrows, every time you go an even number of arrows, you're basically moving along the diagonals, right? So like you can see here, whichever's closer along these diagonals is the ones, you know, however many diagonal steps it takes is more or less how common or uncommon these are if we use our conditional formatting, right? Like these are kind of in the middle, right? Because it's kind of 6 diagonal, 1, 2, 3, 4, 5, 6 diagonal moves, or 7 to get to this one. So these are 7 away, these are 6 away. And yeah, because I only did 10,000 trials, actually, I mean, I think these 2 cells are the least if you have the actual formula, which is ridiculously complicated and not outside of my math ability, for example, at least to have memorized without looking it up. These 2 cells are actually the least common, I believe, in the whole map, even though this was less common in this trial. I knew that's not the answer. I mean, partly because I knew what the answer was, but also partly because these rare ones, none of them are hearts, right? The only one that's hearts is the right answer, which is the 7 of hearts. All right, that's it. Bye.